minutes presentations for every team that joined the hackathon. Every team got a body, they're all lined up over here. And there's a little indoor navigation course that they're going to try to complete. We'll follow with the live stream so you guys can follow along. And start by handing over to the first presenters.
Hey Harold, no one's in yet. Maybe we should wait. We give them like 30 seconds
Sure.
to move over to this one.
Okay, yeah. We can just wait for people to roll in.
Yeah.
Do you want me to post on this?
Maybe you can reply to the Twitter. We got our first person.
There's 44 people waiting.
I can add everyone on Discord.
Okay.
But they can replay back to the beginning, right?
Yeah, but I mean,
Okay.
people want to watch live.
Live experience.
I mean, we have 40 in the other one too.
Yeah.
We thank you guys all for coming.
Wait, you really couldn't get this one to work?
No, it gets on the unable to create stream.
Alright, I'll just delete your announcement and
Okay.
do another one.
Sounds good. All right, the people are starting to roll in. Let's give them like maybe 30 seconds.
Handle the Twitter one too.
What's Twitter?
Well, I tweeted it.
Julius is trying to post it on X? Same way.
No, I don't have Twitter. I'm not Twitter app, you know.
Well, he's got a lot of time to brainstorm, figure out what he's going to do.
Yeah, we got another training. We gotta fix that up.
Sounds like the Discord
Where's
just went out.
Hotz? No, I'm right here, guys. Right here. I'm joining the live stream. Are you in there?
Right, we're ready?
Yeah, let's do it.
Go ahead.
Alright. So I guess we're a team. Is this our team name? Church of End to End?
Yeah.
Okay, so we're team Church of End to End. Initially I wanted to do LLM control, but that is pretty hard, so you'll see the guy that tried to do that later. But then we were like, okay, might as well just try to do complete end to end. So we started running around with the comma body on a stick and then getting a video of when you have to turn left, right, and go straight. And then, yeah, basically just tried to get that to work and run. So,
There's some latent space painting.
yeah. This technique can best be described as painting the latent space, where we walk around and we essentially tell it at every point whether we need to go left, forward, or right. And it has to be completely manually labeled, and for every new environment or lighting change, you need new data. So that's like the one downside. But we did manage to get it at least running from here to the back corner, and then from the back corner to the outside do the loop. But we have not gotten them both to work in series, so I think we're just going to do the first half today. Yeah, I've got this video of great artist steal. So the first person to finish the challenge kind of. Yeah, I guess we can do it.
There's a video of the MOS.
Oh yeah, we have a video. I guess we'll show the video at the end because it's not going to work right now. Yeah, so this is like about 10 minutes of just running around and trying to paint the latent space that the direction you want to go is right everywhere. Alright, with that I think we'll jump into this demo. And disclaimer is I don't actually know if this is the model that worked. I don't know one time that we didn't get this to work, so.
Harold, I think we should do an overview of what the course actually is first. I think none of the people on the stream have seen this.
Oh yeah, we can maybe just quickly run with the streamers.
Yeah, let's do a walkthrough first.
Yeah, let's do it.
And then do you want to redo your intro? I know a lot of people joined after.
Yeah, sure. I can talk about it through the intro. So let's just walk through the course here. So we start somewhere in our office, and it's a small indoor navigation challenge. So the bodies have to navigate through this hallway. go all the way through, all the way to the end. As you can see, the first part's just straight, so it's not that much of a challenge. But there's a gradient that becomes harder and harder as you turn. Now you see the narrowing doorways. Yeah, so every team that came to the hackathon was provided with a body, and over the last, 48 hours or something like that, little bit. To go outside, you go over these ramps over here, so you still got smooth terrain. And then the challenge really starts to ramp up. A lot of the teams had difficulty here with the changing lighting conditions throughout the day and night. So we got to turn around the traffic cone, and then finally this is the end of the course. So if any team succeeds, this is what you'll see them do. And I guess we'll head back in for the demo of the first guys. Yeah, sorry, it seems like we lost the stream there for a second outside, but basically you just have to head out, go around some cone, and end on an X on the ground. And that's it. All right, we'll be back here in a second, see the first attempt of Luigi trying to do this course. Adib, you want to take back the stream?
I get this much time that you got. It's over.
Are we ready for our first try?
Never seen this many people before.
Let's see how nervous it gets about that side.
All right, pretty good start. Pretty good.
So. Oh, the door's open. Oh, the door's open. Oh, it doesn't care.
Okay.
We should,
Oh. Is it going to recover?
It should.
Oh.
hopefully I guess right.
6 out of 12. No, no.
No.
Oh, no.
That's the light.
Is it going to recover?
Oh, it could. It does want to go to the right.
Let's get in there.
It's good in there.
It's making so much noise.
It's good. It's gonna get there. It's gonna get
It's gonna
there.
get there. Oh my god. Come on, Luigi.
Oh, he knows where to go though. That's the important part.
He knows where he wants.
It's just not backing up enough.
Yeah.
Just like FSD.
It's so close. Come on, Luigi. Let's see it.
It's like 1 inch. Oh. Ah, no. That's all right.
This is so
It's all over.
All right, let's head back. So that was Luigi from the Church of End to End.
I did it. It did it.
Oh, so you still trying? Oh,
Whoa.
It's stuck again. It's stuck again.
oh,
I don't think it'll work fast here.
that was anticlimactic.
Just needs 10 more tries. No, it is good. It's gonna do it this time.
We never got it to back up more than this.
You just need to increase your backup time.
It didn't make a difference for some reason.
Oh,
Alright, last one.
Whoa.
no.
I'll go much better than this.
Let's
This
call
was-
it.
This was before the outdoor data, I think. Let's give him a cap.
All right, let's see the next contestant.
We're going out for the other perspective?
No, we ended that run.
I don't see the trade on
Oh, it's doing it. What is this?
They might be carrying it.
Oh, he's helping.
Yeah, they're helping it.
Yeah.
I think let's move on.
All right, let's move on.
That was Luigi.
Let me do a bit of an intro for new people. Just how many people we got on the street?
48.
48. Where are all the people? I added everyone. Should I go live on Twitch? All right. We'll have the.
They're asking if you're asleep.
Am I asleep? No, I'm on Taiwan time. It's Taiwan morning right now. It's early in the Taiwan morning. Okay. So this is Common Hack 4. I didn't do anything. I just showed up. I'm kind of a participant. These are the bodies. You can buy them in the comma shop. They're all topped by beautiful comma 3X's, also available in the comma shop. Almost not even on back order anymore. These things can do things. For the first time in history, we were too ambitious when we first launched the body. When we first launched the body, we thought it was going to balance on 2 wheels. That was too much. Now, it has training wheels, and it's much more reliable at driving around office parks. And what we're doing here is we're navigating around an office park. So what you're seeing is people trying to navigate from here around a loop in the comma office back to here. Or around that sign or something.
Yes. Halfway.
Halfway is good too, but avoid the walls. Walls are bad. So if you watch, if you're watching at home, if you hit a wall, it's bad.
They're saying they don't really hear the people up front. I guess I can get closer.
And then Mike, you're next.
Yeah,
Okay,
let's,
let's
go.
Ending was this.
I wasn't trade on outside.
Yeah, I know. Oh, yeah, ahead of it.
I thought you weren't allowed to touch it.
Did you guys
Well, I mean-
the gym door?
You're allowed to touch it, but.
Oh, we should close it.
Well, you can't close it for one run and not the other one.
Yeah, I don't know if that's fair.
I close it.
Everyone gets open gym door. Oh.
That's fine.
I'm gonna go to the bathroom.
We didn't go.
Back in the sun.
Yeah, I drove to the bathroom on its own.
Yes.
You can check out my code's open source now too.
Oh, good.
Are you gonna demo yours as well, George?
Demo, sure. You got it.
Does it work with all lighting conditions? Or we'll find out.
At night, it's in a full autonomous loop. That's all I know.
I see.
Alright guys, thanks for joining me. Thanks for participating with me. I met a lot of cool people here. I'm having a great time. And I want to show you guys what I came up with. So this is Leon, Napoleon, as I got assigned. And we've been having a great time, me and Napoleon. He became my good buddy. He follows me around. He gives me space when I need it. He records when I need him to. And he's my companion. So I'm going to take him for a tour around the office. The way Napoleon works is he just finds the biggest person in his field of view and he follows that person around. And so that person, is going to be me. And we're going to go for a walk. I'm going to set him up. And yeah, let's do this. Now, while we make our way through here, try and not make yourself look big. All right? just for this one part. The rest will be just fine.
Oh, turn to you.
Hey, Napoleon. Good morning, buddy. Okay, just like we practiced, all right? You got this? Okay. We're gonna go around here. Don't be shy. Don't be shy. Just follow me. Yeah, just ignore them. Ignore them. Yeah, we got this. Let's go. Let's go. That's right. That's right. No, no, no. You go there. Yeah, yeah. Look at me. All right, now let's go. Great. That's what I'm talking about, guys. Eye contact. Don't even. No, no, no. Keep coming. Do not turn your head. Yeah. I know. Listen, it's me. All right. It's me. Come on. This way. Over here. Here, Napoleon, I'm going to give you a little hand just because. There we go. All right.
I'm tiny. Look, I'm a little guy.
I'm big.
I'm little.
I'm big. Come on. Let's go,
I'm
Napoleon.
little.
No. It's not Napoleon.
Go this way. Come on.
I should have worn my hoodie. All right, here we go. Yeah, now we're out of the trouble zone.
Look how small I am. Hey! Hey!
Now let's go. You follow me. Touch that. Perfect. Just perfect. Just fine. We'll play the go around. Let's start from this one. That's right. Follow me. Let's go here. Perfect. That's right. All right, now let's go this way. There we go. That's what I like to see. Keep coming. Keep coming. There we go. Awesome. All right. Now
All right.
push back a little bit. Back up. Back up. Back up. Perfect. Okay, now follow me this way. We're going to go straight shot back to see everybody, okay? Let's go. Don't go down those stairs. Don't go down those stairs. We're talking about this. Yeah, over this. Give us some speed. You got almost. There you go. Good job. Can't go slow over that. You know, you always get stuck there, don't you? Almost home.
All right, a full loop.
Great. Thanks, Napoleon. Good job.
All right, we got a good number of people in the stream now.
Yeah, welcome everyone who's new. Just had two of the teams present. Who was next? Do we have someone sign up to be next? Is anyone ready? Yeah, if you're ready, let's do it.
We're ready now. Start doing the cool thing. Don't you late.
It's risky. It's very risky. Yeah.
The untested model. It's sitting right there. Tantalizing to have smooth.
Yeah, tweaking the
Hey man, it's augmented.
thresholds and
It's got
that
augments.
to,
Just adding like a random text and then so cover it. Just don't always
Yeah, then we can show the guest.
The stream resolution is okay?
What's the
Sometimes they just get low.
just add in.
I think
It's always going to be plus or minus.
Hey, somebody says
Quality equals potato.
I don't know if there's some way to fix that.
Also, I agree. Do you think we should keep the frequency?
I mean, yeah, if the Wi-Fi is slow here.
Hello. Hello, everyone.
I don't know, like we also don't want to just like.
Oh, let's do like 20.
videos, some of them are left, some of them are right.
Yeah, we had some pretty fun here for today.
Oh, yeah.
Yeah,
That's my controls are on the computer and the
is
device.
a kind of open source,
What about lighting and?
aficionado, and he really likes to use it for them. So hopefully they'll see it one day. So for now I just gave it my t-shirt. That's something pretty cool. Anyway, so how we build this? Okay. So this is the architecture we used to. So we take the data from camera, we convert it to RGB, and then we feed it to the segmented NSA model. We use mobile version, which is a little bit cheaper, and then we feed the floor plan into custom models that we built and trained here on the spot, which we call director, and then how it looks left, right, and forward. So this is the architecture. We started with YOLO running on the laptop. We didn't have time to move it to the device, so right now it's a little bit experimental, but that's how it works. Essentially, all the data is received in the main thread. We moved inference into separate thread. The reason for that is that inference is still quite slower than real time, so we need to drop some frames. For that reason, we basically just process the latest frame and drop the rest the rest to it, and we spit out control messages as we go. And we also built a little bit to aid with the training. We also built a little bit of telnet interface. We use telnet just because WebRTC client is a little bit slow.
Wait, like actual telnet?
Yeah. Well, telnet, I mean like socket server.
Yeah, I haven't seen anyone use telnet.
No, like I mean, we use.
So like the data has been more.
Yo, I got my 28.8 modem. Got a telnet somewhere.
Yeah, but you can use it. But it's pretty useful because right now we can basically just do. We started with fully manual run, so basically we gave it commands and it recorded all data and automatically labeled. So basically we didn't have to label anything. But once it got a little bit running, we also added like a run mode and step mode. So in run mode is basically just runs inference. In step mode it basically runs it once and then pauses for the command, makes another inference and so on. And also we can in the real time send it, even when it's in the run mode, we can send it correction command. So if we see that it goes some wrong direction, we can AED it, and it will be recorded and we then can amend the data set and train it this way, improving the model. Okay, so resource utilization, it's pretty good. I mean, we can probably run it on the device if we have more time. So we use, right now for those two models, we use about 15 minutes of RAM, 10% of 1050i, which is my laptop GPU, and it could be optimized more. We get about 5 FPS, but I think it's mostly because of the latency, not really for, we do not get time to watch the performance of it. There are some videos of restaurant. It does okay. It's a little bit slow, mostly because it runs on the laptop, so it had have to wait as well.
So basically, yeah, in the backend it just first detects the lanes, as in like the round part of the which it needs to navigate, and then it creates a small neural network which detects the first right, left, or right. So most likely, since it's more of right, it kind of tries to follow the left wall, and yep, tries to reach as much as possible. But it's slow. Sometimes it gets stuck. That's kind of a steady state.
Cool. Okay, that's our presentation. Now we can.
All right. Did you want to do a demo as well? Do you want to try this?
We can give it a shot, but I'm not sure it's something.
Yeah.
Go to network, advanced. Yeah. That's 16.75.
I think it's better this direction. I can try to flip it.
Okay. So I think right now it's in the step mode.
You guys gotta speak up. They can't hear
Okay,
anything
right now
on
it's
the
in the
live stream.
step mode, so we can.
Yes.
How is it the risky slow? The risky
All right, there it goes.
You know, I guess we're turning left. It actually should be the other way.
What's up, Todd? Super.
Is he gonna get stuck?
But we'll give it one more attempt. If it hits the wall again, we'll have to see if Todd has recovered.
Don't do it. I know it's tempting.
yeah. A lot of good stuff.
And Todd's a real slow and steady.
It's a little bit old.
Slow and steady guy.
Give it a slap.
Conservative.
Let's get to the next checkpoint at least.
Yeah, well, let's see what it does to this checkpoint.
Yeah, no, so the difference with the hitting the wall is the other two runs, the body's recovered. If it recovers on its own, that's fine.
I tried. I don't think it would recover once it is so.
Yeah, no, I was answering, there's a comment about...
Yeah.
There was idea to put, get,
I went
Right, yeah, no, we missed that check mark. Let's cut it there.
All right, let's go to the next one.
Well, let's give a hand for that team. Who's next? Is anyone volunteering? Otherwise, I'm just going to randomly point at someone. Yeah, you guys? All right, let's do it.
All right, and remember to talk towards the camera. So they can hear
Keep your
you.
voice up. I know it's been a long weekend. This team's got Clay Thompson. Oh, you guys are running the other way?
Yeah, we're going backward.
Right, we've got a backwards team.
Oh, nice.
What was the reason for that? Oh, you guys didn't like the infrared camera view.
Or are you guys using the narrow cam?
No, we use the wide one. Just
Wait, they're the exact same.
No,
Yeah.
everything was red.
No, sure, but
The red's
They
kind
said
of
it was-
disgusting looking.
they said it wasn't the IR.
I don't know, just like look at the camera a little bit, like from both cameras. I kind of like the rear one more.
It is
so.
cool that the other one can see at night.
Yeah, I think it works better at night because the lighting's consistent.
The other one works far better.
All right.
I remember to be loud.
Yeah, very loud, very loud.
Live stream.
Let's see. All right, I'll just introduce ourselves. I'm Bo.
I'm Cole.
Edgar.
Then
Oh, sorry guys, one sec. There's a comment that says if we flip it, it'll sound a lot better. Let's try that. Yeah.
oh yeah, that's true.
Interesting.
Rotate
Is
the
that the
palm
goal?
in.
I think it was upside down. It doesn't.
Okay. Okay.
Someday we'll have a good stream. Look at that professional
All right.
tripod.
Nice. We can even see ourselves.
Is it better? Anyways.
All right.
You're out of frame.
Oh, I'm out of here. I see. I don't want to block this. Or I guess the
I
text
mean,
doesn't
it's just
really
check
matter.
for whatever.
Okay.
Yeah.
All right. Well, so yeah, Cole, do you want to give them a brief description of our like?
Sure. Yeah. So for our approach, we went with a end-to-end learning approach. We're using the efficient net model. The initial starting out, we tried to hard code the path because that seemed quite easy. what we learned, a challenge was two things. One, there's a lot of latency on the office internet, and so that skews the commands that we're actually sending to the robot and basically caused it to go off course. After that, we quickly corrected and moved towards a end-to-end neural network, and I'll let Edgar talk about the training, how we collected the data, and then
so we basically try to we label the data set, we carry the robot along the way. So it's facing left, and then try to correct it so it goes back to the right side. And we try to control it with the joystick in this way labeled data set, but it was kind of worse because we had a lot of majority of the class being just go forward. So we ended up just having making robot face left, carry it forward, and make it the left class, and just do the same for right and forward. So this way kind of have balanced data for training. Well, for the training it's pretty simple, just efficient net B0. We'll resize input to 224, set grayscale images fed to network, and we tried a bunch of augmentations dropping out, changing saturation, contrast, stuff like that. So and yeah, it kind of made it a little better. So that's pretty much the training part.
Yeah, and then yeah, I guess just last stuff. Implemented some kind of cool features to help with testing and iteration, engage, disengage buttons, fast loading without having to restart the comma, and and then loading the model on the device to get around latency issues. All right, yeah.
The model's running on the device?
Yeah, so we are running natively on the device. We took the Onyx model and then converted it to the TH-need format, which allows us to use the GPU of the comma. And so
Do you want to switch back to,
here we go.
to the stream?
Yeah, so yeah, I just started the model, and then when I press the C and E keys,
Yeah, we added 2 extra keys on the monitor. You can see the E and C. Basically, when I'm debugging, we press the E and then the AI engages, and we press the C and disengages. So it's kind of convenient.
How did you switch the camera?
We swapped the web app to use a different stream.
Yeah, I mean it's pretty easy to do that.
And straight.
it has recovery though. It has recovery.
It has recovery. Yeah, should do something soon.
All right.
Oh, okay.
All right.
Oh.
That's cool.
Nice.
A sharp turn.
Solid.
Now things getting a little funky, but
YouTube says you're the best team yet.
So it'll recover out of this.
It'll be fine. Just give it a time. Okay. Nice.
Nice. Why doesn't it just do it right the first time?
Good question.
Oh.
Solid.
Wow.
That's kind of the tricky part because we had all data set pretty balanced, but it still has a bias toward the left side. So
You gotta multiply the right probability by 1.1.
it goes to the gym. Yeah, this.
It wants to go to the, should we show off the gym on YouTube? It wants to go to the gym.
All right, let's show the gym. Is it gonna recover?
Come out of that, yeah.
All right, let's give it a chance to recover.
Well, no, but we should show the gym on YouTube while we. Remember, this is all an ad.
All right. Let's show the
By the way,
drill.
while Clay's hanging out, I mean, he's got a basketball jersey on. Clearly, where he wants to be is the comma gym. We have weights and bigger weights and a treadmill at the comma gym, where Clay wants to be.
I think it's done.
Call it there?
Yeah, let's call it.
All right, that's what we made it to. All right.
red. I actually see like little vision. I like that.
More like a video.
Yeah.
Does it sound better turned around, guys?
No, you want to close?
All right, who's next?
We can go next.
All right, yeah, let's do it.
Good. Should we use your laptop?
Yes.
Okay.
Wait, I'm just gonna do a quick check of who's left. So 3 teams left. Right, got three left after the current team.
Alrighty.
Okay, they say it's better.
Just can't wait for like the GPU to
They would do this one, but all of
back
these
alive. I saw him sleeping and dead over there.
Yeah, no, he's had a fun past few days. So, but yeah, our team was none other than the great Julius Caesar in the flesh, or in the metal, I guess. And then our approach, we tried a whole bunch of different things, but what we settled on doing was doing an end-to-end model. But instead of just using the like raw color data, we do a depth estimation with just an off-the-shelf network, and then do end-to-end on the depth estimation. We originally wanted to just do kind of like a traditional 2D SLAM with the depth estimation, so you could take like a horizontal slice or something like that, and then map out the building. But that was, less trivial than we thought it was. So we ended up just kind of doing this end-to-end. So you can see the real-time color video there on the left, and then the depth here, and then we just kind of run that through the model. We kind of did the normal end-to-end training routine where you get some good training examples where it's kind of facing forward, some where you carry it and it's like facing left, some where you carry it and it's facing right. And that worked like decently well. We were able to get from like checkpoint 0 to checkpoint 1 somewhat consistently. Maybe it'll struggle with all these people in the room, we'll see. But since we have the depth data, there's a lot of potential for augmentations and stuff. So you can take the depth and you know where you're facing, and then you can translate the camera to the left, to the right, and do all these things like this. So here's kind of a demo of that.
It's also invariant to the time of day.
Yes, so that's another big benefit, is that lots of people struggled where like they get all their training data at night and then it doesn't work in the day. The idea here is like, the depth estimator is trained on both daytime and nighttime images.
Why is it like wobbling?
So this is us trying to augment the data. So we took one picture and then we're using the depth data, projecting it into 3D, moving the camera, and then reprojecting it back into
A little bit like the stuff comma does.
Yeah.
So,
that's
there's a little bit of some issues. No
Yeah.
need to talk. No need to point it out. It's too tiny for you to see from all the way back there.
Yes, exactly. But yeah.
I can tell.
Looks familiar.
Yeah, it looks familiar.
It's very familiar.
Yeah.
Are you running on device?
Sadly, we're not. So since we're running 2 models, we're like almost like really, causing this GPU to struggle. So moving it onto device is definitely doable, but we just haven't done it yet.
Okay.
All right, should we demo it? And then the model itself for our end-to-end is just a ResNet 50. And then the depth estimator is just like the top depth estimator on Hugging Face. So is this the demo?
Yeah.
Here we go.
Okay, deep maybe. Get out of the way. All right, well, good start.
Yeah, we'll see.
Yeah, it's never seen this many people before. So.
Uh-oh.
Uh-oh.
Nah, it's over.
Is it gonna recover?
Oh!
All right.
Recovery?
No recovery.
Okay, so we'll standardize one manual recovery.
Yeah, one manual recovery is fine. Just for entertainment.
All right.
When it's more confident, it goes faster.
Yeah.
All right, that's it for Julius Caesar. All right.
All right, let's give it up for that team. Right, and then we've got 3 more teams. Yeah, go ahead. Is the demo ready?
It should be, yeah.
Great.
That's
Did you want to reset that cone outside?
Oh, yeah. That'd be great.
We're planning to get that far. You want to do it, or you want me to do
We're
it?
making it outside,
I'll
is
run
what
it.
I'm hearing.
That's ambitious.
Are we doing the demo outside?
They'll just be setting the code.
Oh, okay.
Yeah.
Cool.
What do you mean can't go around?
Oh, yeah. Well, it's still impressive.
Yeah, that's cool to capture. Yeah.
Remember to talk loud.
Yes.
Yeah. Okay, we are Team Spike the Biker. I'm Ellen.
I'm Rian.
And I'm Armand.
Yeah, and so for our model, we have a sim to real, and we train in simulation in Blender, and then use the PID trajectories to follow the line, the desired center path more closely, and then use that to train an efficient net classifier to then predict the action based on images, and then Aman, do you want to explain the...
And so what we started by doing is like mapping the office. So we used the iPhone LiDAR to get a 3D scan, and as well as the floor plan. And then from that we trained a simple PID to get some trajectories.
Yeah, I saw that. True. So yeah, that's the Blender project. We did import like basically just a quick scan with LiDAR. And then I tried to add some artificial lights that basically at the same spot of
You guys want to
real
zoom in a
lights.
little bit?
Do you want to play the keyframes?
Yeah, I'll play it. It looks like this, and there is also an animation that we made. Okay, so that's the kind of trajectories that we created. Maybe you want to explain how we created?
Yeah, just a simple PID following the line. And so then we just put those trajectories into Blender and move the camera around. And then from those images, we predict the output of the PID, which is just the steering to the robot. And that's, yeah, that's basically it.
And
Do you want to show the images?
yeah, just the PID is like, basically we took the floor plan and we draw a path and then we tune a PID to follow it. And then yeah, using this, matching with Blender, we match like a pair of images in action and train a CNN. Yeah. Should we go for demo?
Oh, do you want to show the other images?
No, the filtering as well. It was also kind of difficult to get good trajectory using only a PID. We initially wanted to train some reinforcement learning, but it was a bit too short. And so what we ended up trying to do is, can you go to the filtering?
Was that an augmented picture? Go back.
Oh yeah, that's important. We matched the images in Blender to the images from the camera, obviously.
That's a fake, that's a simulated picture.
It's like a simulated picture, but
so it has Blender on top of the actual real image.
It's like to compare the images.
Yeah.
So yeah, so we like used the camera calibration and warped the images to match the fisheye of the camera.
Yeah, and then we also have augmentations for the actual image, so like color tinting and everything. So it ends up looking really similar.
Do you have a picture of it, just a full simulated?
Maybe somewhere on the.
You know what I'm saying, right? Just the screenshot of a
Yeah,
simulated frame with all the
like
matching augmentation.
Augmentation we don't have, but we
Probably like the fisheye and stuff.
Yeah.
Well, this is a
in
very
the vendor check stuff.
Yeah, I didn't see Blender output the fisheye like realistic.
Yeah, basically, yeah, that's the issue. We do it like after Blender also, for like compute reason, because it's too slow in Blender, and also like we don't know what model they use.
Are you guys like training network purely on the Blender images, or there's a real images like mixed in?
No, just the Blender images.
And it like translates.
Yeah,
just like
pretty well, yeah.
We'll find out.
Yeah, we'll find out. Yeah.
I just know.
Yeah, and yeah.
So with
Yeah,
so with Blender we can sample a lot more trajectories. We have 200,000 images, and we also sample along, like in different locations, kind of skewed away from the path and have it conjoined back to the path, and then we stop it. So actually we should have had the distribution of the predicted actions, but most of the time it's predicting left and right because we don't want it to be following the path, and that's not very useful. So we stop it after a certain amount of time, and then we have it sample a different location and the PID to get a lot of different trajectories so it can recover quite well.
Let's see the demo?
Yeah.
Yeah,
Cool.
okay.
Yeah, they already did.
Oh.
Yeah.
Or do you want to put the...
Oh, do you turn it on?
Yep. Do you want to put the image?
Oh yeah, can you project this? Yeah, okay. we should be good to start the model.
They want to know if it's all running on the device.
Oh, I started it. Yeah, it's running
Cool.
on device with also like the other team with Onyx and THNA, so running on GPU.
All right.
Pretty smooth so far.
It's pretty good.
Oh, oh, you recovered.
Stressful.
No, you can't close it. We got to deal with it.
It was closed on the simulation. Like the simulation.
YouTube says you guys got off to a very clean start.
Yay! Let's hope it stays that way.
Yeah.
The gym seems to be the next checkpoint.
Yeah, yeah.
We have a few points.
It's
Intentionally not ahead.
often tempted to go to the gym too.
I think let's hang out here because it cuts out around the bathrooms, and then if it goes around, we'll go there. Oh.
Whoa.
Oh.
Nice.
Okay.
Oh, it's gonna turn? No, so passing the X isn't bad. The X's are just checkpoints.
Oh no. Oh no, turning away.
He just wants to go back inside. All right, nice job, Spike.
Congratulations. Best run so far.
Yeah.
YouTube agrees.
YouTube agrees.
Yeah.
Great.
Conspiracy.
All right, nice work. So we got two more teams. So, ChatPID, are we good to go? Ben Swallow is ready?
Please give
Ben Swallow?
Bro, I feel like a lot of code while I was sitting here.
Dude, please get it over, please.
It was really bad.
It'd be hella funny.
I think if you change code after other people have presented, it's not a good omen.
Yeah.
You guys closed the door. We had to deal with the gym opening the door.
We will set the doors however you want for your run. If someone insists on a retry.
Yeah, but remember how shameful it's gonna be if it doesn't help.
That's right.
Maybe you want to drive it up a little bit.
Just give the stream a close-up of Ben Swallow.
Just a quick close-up. Let's get a good look at him right there. All right, I'll move him back now. All right, everyone, YouTube, this is Ben Swallow here. My name is John. This is James. He's actually off screen, so I'll move.
Yeah, I can explain the training. So basically, what we did to set up Ben Swallow here is we captured frames by driving around the office using just the WASD keys, and then matching the frame with the key at that actual timing. And then we used that to train or fine-tune ResNet. So if I go to the B here, you can see we processed some of the images and then basically fine-tuned the model from there. We didn't end up collecting enough data because I wanted to use visual language models, and we set up blip2 on our AWS instance previously, but it ended up not working and hallucinating a lot, so we ended up going with this method. But we didn't collect a lot of data, so it's probably going to just crash into this wall here. So let's see.
Maybe. We had a couple runs where it was all right, but we haven't tested in a little
Probably
bit.
crash.
The one thing that we did do that a lot of teams didn't use is we used Canny to filter out any possible issues with color, so it'll work both at night and in day. Well, it can crash into walls at both night and day. All right, the other thing that we did that I don't believe anyone else is doing, we're actually running our code in AWS, which is getting streamed down to the device here through Tailscale. Tailscale is like a mesh VPN solution, so you can just install it on any device you want, and it just, boom, networks them together. You don't have to worry about anything. So hopefully the internet is stable enough and it all works. So without further ado, let's give you a demo and show you what Ben Swallow can do.
Yeah, the stream and AWS are going to be competing in this run for bandwidth.
We literally have fiber. We pay $5,000 a month.
Yeah, our workstations are genuinely 10 gigabit. But
All right, let's give it a go.
Why? Which is worse?
Swallow going straight to the bench press. That's a bit ironic. It doesn't get to the gym.
All right, here we go.
Last some more. Oh, great. Good. I hate paying money.
Oh, there it goes.
right, Ben Swallows.
It's gonna go straight to the camera.
Get it, boy!
One retry, one
manual correction.
We did this originally when there were. We did this originally when there were a lot of food tables here. So the training data is a little bit messed up.
Start after the food tables.
We'll start after the food tables.
Let's see if it
Is
goes
that
to the
right?
gym.
Yeah, let's just do one quick one.
It's gonna still crash.
All right.
For the entertainment value.
So fast.
Straight for the gym.
Oh. All right, you missed the checkpoint.
All right.
All right.
Let's give it up for Team Ben Swallow.
How much did it bench?
Everything.
ChatPID.
This is gonna be tough, guys. This is gonna be tough. This is gonna be tough. Let me just make sure it's right.
Yeah, presentation
on the
as
TV. Okay, I think we're good. Oh, do I need a presentation? You don't have to.
I mean, yeah.
I can present my dev post. Yeah. Yes, please.
Also written by ChatGPT.
Is it? Yeah, is it a ChatGPT dev post?
Actually, yeah. ChatGPT wrote the dev post. That's why it's like kind of nice. As you can see. Oh, you want to see where I did it? Actually, I did it right here.
Oh my gosh.
So
ChatGPT wrote the code too.
ChatGPT wrote the code. We're in cursor. All right. Yeah, it's ChatPID. I guess LLM's doing controls. It's kind of the future. I don't think you guys.
Maybe go out of this so I can see the image you showed.
Which one?
The first one. That's the most relevant one, right?
This one?
Yeah.
Yeah. So, basically, I'm doing SAM, but I guess I'm dumb and I didn't know there was a mobile version. So I'm actually running it in a A100 on modal. So that would have been nice to know if you had told me that earlier. Yeah. So PID is like $1 a second or so. And, yeah, just to go through it real quick. So we run the camera. We get this image, and then we run SAM, but SAM doesn't label, so I have a heuristic labeler, which is actually the first image. That just gets floors and walls based on how big it is. And then
That's how it works?
Yeah.
Sam doesn't tell you the class?
No.
It totally tells you the class.
No, it doesn't.
It's the color. Just do by green.
Yeah, it's the color. It's ID. Then
And give you logic.
It doesn't tell you what it is though. It doesn't say floor.
Just do it by green or something.
That's what I did. That's what I did. Anyways, that's what I did. This is good though. So this is the floor, and then walls, and then blue is other stuff. And then we get this, and then we get a really nice ASCII image, and then we feed this ASCII into ChatGPT. So, yeah, it's all written by cursor. And the prompt's like pretty nice and beefy. Yeah, we can read some of the prompts. So, let's see. You're a self-driving model embodied as a 5-foot-tall two-wheeled robot. You're currently on a racetrack, and your task is to navigate. I can show you the ASCII log. So I give it this is like the floor. This is its current location. I have like a top left just so it kind of knows what's going on. And yeah, this is what it sees.
Holy shit.
This task is a human.
Yeah. Well, anyways, let's see what it does. I guess. Let's see what it does. So we'll see in the bottom here what it's thinking. I guess. So that's there you go. So that's from So it wants to do. Oh wait, it's okay. This is the first. This should be the first one, I think.
So we're running out.
Is it using 3 or 4?
4.
GPT.
It's 4. Yeah.
This project's all about spending money in the cloud.
Okay, so we got it, right? So W-A.
It outputs the key.
Yes, it outputs the key from the bottom. So you can see. So that was pretty good, right? The control loop's like roughly 0.01 hertz. So it's going W. We made it pretty far before, but
Can you guys get to explain what it's trying to do?
Yeah. Well, it says. So it makes a plan. So the plan last time was to move forward slightly, adjust to the left, stick to the left side of the track, continue to move forward, make micro adjustments.
What do? You drive down cars.
Yeah, dude. So okay.
No. Can you yell at it? Can you tell it?
When GPT doesn't follow the right structure, it just goes backwards. So we got listed next out of range.
Can we get it to at least recover from going into the wall? How long is that gonna take? Let's wait another 30 seconds.
I have 90 seconds.
Yes.
What is that? $90?
There's actually an A100 thinking about this problem.
Yeah, we can see it think right here.
My God.
That's my control loop time. That's my A100 bill.
Dude, the numbers are crunching.
That's
ChatGPT.
Pretty good.
It's good. ChatGPT wrote this to extract most money.
So yeah. Maximizing profits. So this is the future of control systems. Let's go. Pretty good.
Now, the next one comes after 1 minute.
Another $5.
Let's cut it here.
Yeah, let's cut it here.
All right.
Thanks again for ChatPID.
I guess I should.
What's your bill right now?
I spent $50 on Modal and $100 on GPT-4.
Georgia, do you want to demo yours? Or
I can try. I don't think it's as good. I think the Blender can beat me.
let's see it. If you can try it, let's try it.
All
Right, George has a solution too that we're gonna see
I
if we can
saw
stop.
some people holding the thing like this, like they were walking up against the left wall
Wait,
like
let me-
this. So I shamelessly copied their strategy, and was like, with engineering prowess and existing knowledge of the comma code base, maybe I can win. It's open source right now on my GitHub under body loop. I also put it in speed mode for maximum entertainment. So we're gonna see. We're just connecting into the body here. Let's go in.
Who's the first one to do it?
Yeah. So just here it is. It's it's called Common Body Loop Driver. I did all the training and inference in TinyGrad. The thing that I'm most proud of is that I have control.py, and control.py can run seamlessly either on the device or on the computer, and it'll loop it nicely on the computer, or it'll just run locally on the device. I didn't have to use Thneed. I just used the TinyJit. So I collected a data set. Yeah, I can just, maybe I'll show you like what the data set looks like.
It works. This is a 0.1 hertz.
So like this is an example of when you're too far to the right. You just recorded this data.
What labels you have is just like left.
I just labeled the entire video. This is a right video. There's left videos and right videos. Here I can show you a left video. For comparison.
How many videos do you have in left and right?
So I gathered lots of videos, and then I actually got it to drive the entire loop once during the day and once at night. Every time it would mess up, I would just record a mess up video. So I can show you what these mess up videos look like. Like this is my data set here. So we can look at like mess up 1.
The mess up video is also going to be like one class, or
Mess up videos are just one class. This is a mess up where you should be going more right. See? So like if it's over there, you should be going right. All right, let's see if this works.
So did you clip the mess ups to where they should have done something else?
Yeah.
Makes sense.
So I put it in maximum speed mode. We got to compile the model here.
This is kind of
Whoa. Wow.
Very smooth.
Could not acquire media, permission denied.
I missed the checkpoint.
Oh yeah, I don't do the checkpoint. Oh, did I hit the wall there? Just correct it that once.
All right. All right, let's go, Jeff.
Yeah, I put it in speed mode. That's why I hit that wall there.
Jeff's got no interest in the gym whatsoever.
No, Jeff.
We'll give him one more.
Jeff is speedy.
Oh, let's go, Jeff. Jeff wanted to take a quick leak. Let's see if he does it.
Oh no.
I'll give him more recovery, Mitchell. You gonna do the turn? Nope. All right, he wants to go back.
So close.
All right, let's carry him in.
Too speedy.
All right, YouTube voted Jeff as second.
All right, that's it.
Right, let's give it up for the in-house solution.
This is the speed he's designed to go, but he's less entertaining.
I guess we'll see how this goes too.
All right.
It should work a lot better at this speed. I don't know why I went for the high speed. I did both of my complete loops at this speed. See, now it can actually make that turn.
Yeah.
I shouldn't have went for the high speed.
Let's see if he's interested in the gym now.
No, he's good.
He really misses all the X's.
Oh, he went
Oh,
that
no.
way. Sometimes he goes that way.
You want to correct it?
He might correct himself. He doesn't like X's. I tried to train a generic model that would go like anyway.
Yeah.
So the problem with that is sometimes it goes that way.
Outside wasn't too bad last time.
Yeah,
Maybe I'll do it this time. You gonna present, Mitchell?
I'll ask you soon.
No, Jeff.
Never mind, Jeff, you suck. You suck, Jeff. Learn to drive during the day.
Better get back his $100.
You should kind of avoid obstacles, too.
Alright, let's go back inside and I think we're gonna end the stream and then we'll deliberate and do some judging.
All right.
And we'll tweet a picture on our Twitter of who will decide the winners are. George is not eligible for a common prize.
I ran out of money on 11 laps.
So yeah, but thank you guys for coming all on the stream, and check in on our Twitter if you want to see who we decide the winners are.
So buy a comma 3X. It'll ship Monday.
Buy a comma 3X.
Bye, everyone.
And buy a body.
Bye, Jeff. Bye, Jeff. Wait, Jeff, I'm talking away. How's it going?
He just keeps grinding.
Bye-bye.